What's going on, guys? My name is Brandon, and last week we ran a bunch of wire through a budget Harbor Freight 125 flux core welder. It's a $139 welder. Well, the results are in, and I ended up switching wire after like 5 years as the result of that test. A lot of you guys have asked me, what if you run those same wires through a high-end machine? Would the results be the same? Well, today we're gonna find out. Stick around. All right, guys, I want to get you up to speed. If you haven't seen last week's episode that I just referenced, check it out. I'll put a link up above. But I sourced out wires from Matheson, Harbor Freight, Lincoln Wire from Lowe's, Tractor Supply Hobart, and a local brand from the auto parts store, which is Vapor. And I have run Matheson for years. And after our test during that video, I actually switched over to Lincoln Inner Shield. For that machine, we used a flux core welder, 125 by Harbor Freight. Now this machine, as of the time of recording, is $139.99. Well, what if you run these same wires through a machine costing 17 times more than this? Well, that's what we're gonna find out. This is my Fronius Trans Steel, and as of the recording of this video, the price of this machine is $2,404. Now, I'll have links to all these pieces of equipment down in the description below. I'm going to be running these wires in order of cost by the pound. So the Matheson wire was $9.38 a pound. The Vulcan wire from Harbor Freight works out to be $10 a pound. The Lincoln wire works out to be $12.97 a pound, and they only sell this in a 1 pound and a 10 pound spool. So you'll also see I have the 10 pound values in the bottom left corner. The Hobart wire is $13.96 a pound, and the most expensive of the bunch is the Vapor wire from O'Reilly Auto Parts at $15 a pound. And here's the procedure, guys. All the wire we're testing is 30 thousandths self-shielded flux core wire. We're gonna set the voltage on the machine to 1/8 inch material, which is what we're gonna be welding on. The working lead and the workpiece are not gonna be disturbed or moved so that we're not changing resistance because we wanna keep the tests equal. And I'm also gonna run this machine on 120 volts so it simulates the same voltage that we were running the Harbor Freight welder on. And just to recap, we're going to be running all the wires in the same order that we ran them before and see if the results are the same or not. All right, one of the first things I got to do, guys, is I got to switch out my solid wire that I'm on right now and switch it over to the self-shielded flux core. You can see I'm on a dedicated 120 volt outlet right here, plugged right into the back of the machine. So like I said, I want to keep all these tests equal and the same. So the first thing I'm going to do is I'm going to take my wire and trim it off on the end just in case there's like a little ball. I don't want it to affect the liner. I'll come down in here and we'll release the tension mechanism, and I will just start coiling up the spool that's in it. And for this, we're gonna have to change out our drive rolls too, because with self-shielded wire you have to run serrated drive rolls. Feel it. There it is. Now I want to duplicate everything as much as possible as we can, guys. So I'm going to take my workpiece, I'm going to clamp it down to my fixture table so that everything is nice and snug. That duplicates what we did in last week's episode. There's last week's test piece. We're going to be running them all in the same order. We have our ground lead down to our fixture table. We're not going to disturb that. We're going to leave it put so that there's no change in resistance, and we're going to leave this put. We're not going to touch anything. So now we got to go set up our machine. Now it's important to know when you're running flux core wire that your stinger lead has to be negative. So in other words, so your ground lead, your working lead, whatever you want to call it, you're going to put that into your positive terminal, or make that positive. All welders are a little different, and make your stinger or the gun negative. So that's what I'm doing here by changing these around. Every machine will be a little different. Some have a selector knob, some have DINS connectors like this. My Hobart actually has some mechanical connections that you have to switch around. Just make sure that your gun is negative. when you're welding with flux core. So the next thing I'm going to do is I'm going to turn it on, and as I said, we're set on 120 volts, and now we got to select the wire that we're using. So we're going to toggle all the way down to self-shielded. Now we need to toggle to our wire diameter, which is 30 thousandths. We're going to put this in manual mode. Like in the last test, I'm going to try to run all the wires on the same setting, but if I need to adjust them to give the wire a little bit of the benefit of the doubt, I will make some small adjustments, but I'm going to try to keep the settings the same for all the wires if I can. Now, before we start running any beads, guys, I just want to take a minute and talk to you about safety. You're going to want a pair of nice welding gloves. You're going to want to set yourself a respirator because there's a lot more fumes when you weld with self-shielded or flux core wire than there is when you're using like a C25 gas. And you're going to want yourself a nice hood and preferably maybe like a cap. My whole point to that message is, guys, is that I just want you to be safe. I don't want to get too preachy here. I don't want to get too in depth, but this is the only set of eyes you have. It's the only set of lungs that you have. And over time, these UV rays, these toxic chemicals that come off this welding process, they're poisonous, so you don't want to breathe it in. So do all you can to try to avoid it, because over time, what may seem like you're just doing something really quick now, cumulatively over time, that will affect your health. So I want you guys to be healthy. I want you around for a while. I've got a little illustration here, guys, and I wanted to just take a quick minute to explain flux core wire to you, and sometimes why you may have a different feeding problem where it's driving through the machine, it's just not working right. Sometimes that can actually be how the wire's made. So here I've just kind of drawn a quick sketch of a piece of flux core wire. And the way it's made is that there's a seam that runs the entire length of the wire. You can't really see it, but it's there, and it's encapsulating the flux. And what the flux does is that protects the weld from the atmosphere. So this is very similar, this process of flux core welding is very similar to stick welding. Now you're going to see a lot of smoke, you're going to get slag, and that is very similar to, like I said, stick welding. So you want to make sure that you wear your respirator and that you have on your safety gear. I also have a fume hood right here. If you want to see how I built that, I'll put a link up above, and that just exit to the outside. And that helps draw up a lot of the fumes, but an issue that I have is sometimes I forget to turn the hood on because I'm constantly turning it off and on because I can't video with this going. It just kind of gets too loud. And I also have a fan right over there on that side of the room that I also turn on, and sometimes that kind of like blows it away from this little hood opening right here. I really need to add another little piece. The one thing that you guys don't see is that this is where I sit right here in front of my welding table, and I have a little remote, and when I turn it on, that turns on my hood. You can hear that, so that's drawing ventilation there. Then I have a booster next to it that pulls on another fan, and then I have another fan which is right there that cools me off. And that's that. So you can see how loud that gets, but that fan right there sometimes has a tendency, as you can see, it's blowing that little piece of tape. It'll blow the gases sometimes by this hood because it's just too high up above my workpiece. But I just wanted to kind of touch base with that and show you guys that stuff. So we are ready to get welding. So I've got the machine dialed in. I'm on manual mode. I'm running 95 inches per minute at 15.1 volts, and I'm going to try to keep that setting for all the wires. And again, I'm going to be running these wires in the same order that we ran them with on that Harbor Freight welder. So the first one we're going to be starting off with is Matheson 030 wire, and that's $9.38 a pound. All right, guys, I already messed up. You saw me run a bead over here. I actually stopped, ground the bead back down. I wanted to clean the metal surface up so I could get a good surface. Now I'll redo it. So you can see how I got an M, that's for Matheson, and we'll just continue down the line just like we did over here. All right, we're going to pull this wire back and then run our next wire in the lineup. This next wire we're gonna run, that's gonna be the Vulcan. Just like the last test we did, guys, I'm gonna be cleaning the contact tip and the nozzle between every wire, and we're gonna dip it into some nozzle gel. And you guys should be doing that anyways when you use Flux coat wire, because it keeps the spatter from building up in the end of the nozzle. Alright, now we're running the Lincoln inner shield at $12.97 a pound, and this only comes in a 1 pound reel or a 10 pound. It doesn't come in the 2 like the others. The next wire we're going to be testing is the Hobart. This next wire in the lineup is the 4th most expensive. It's the Hobart, and it is $13.96 a pound. The last wire we're going to run is the Vapor. Again, we're running the Vapor wire, and this is the 5th wire in the lineup, and it's also the most expensive at $15 a pound. For those of you guys that watched the last week's video running this wire through the Harbor Freight welder, I could not get this Vapor wire to run. Alright guys, the results are in, and once again, I'm completely blown away by the results. So let me bring you in and show it to you. Alright guys, so here we go. We got the Matheson wire, Vulcan, Lincoln, Hobart, and the Vapor. And a lot of this I think may be subjective, but you could probably hear a lot of it as well. The one I had the most difficulty with this time was Matheson. It was not running that good. In the last video, if you remember correctly, the Vapor wire, I really couldn't even get it to go. It kept stubbing. It actually didn't run all that bad. As far as I'm concerned, the Lincoln wire once again shined, and here are my results. We've got Lincoln coming in first, Harbor Freight Vulcan coming in second, Hobart in third, Matheson fourth, and the O'Reilly wire fifth, the Vapor. And putting them together side by side from last week's lineup, Lincoln once again came in first last week. Hobart actually came in second, and it came in third in this week. Matheson came in third last week. This week it came in fourth. Vulcan came in fourth last week. This week it came in second. And the O'Reilly Vapor wire, couldn't get it to run well last week. Not too bad. So that's how it stacks up, guys. So what I thought was not going to turn out to be a good wire, I thought that Vulcan was going to give me some problems, and it really didn't. So I'm completely blown away with these results, guys. And this is why I do these tests, because it's kind of subjective too, but if you use something, and like I mentioned in last week's episode, so let's say I'm using Lincoln wire this week, and then in 2 weeks later, I go to use Matheson wire. There is a little bit of a learning curve with each wire, but the more you use it, the better you can get with it. But when you go from back to back to back to back, it's really easy to see which ones are just naturally easy to run and which ones aren't. And some of them take more of a learning curve than the other. And for me, as far as I was concerned, the Lincoln wire, just like right out of the gate, didn't require any fiddling with it. It just worked good. So as far as I'm concerned, the Lincoln was first, and I cannot believe the Harbor Freight was second, but that kind of coincides with what a lot of you guys have said and you guys have had good experience with. So it comes back to the question, does having a $2,400 welder versus a $139 welder, is there a difference? I actually think there is, because with the $139 Harbor Freight welder, I really could not get that vapor wire to run. And when I chucked it up in the $2,400 Fronius, the thing ran it pretty good. I didn't have to do anything. If you noticed, I never changed the settings, not once. And on the other welder, I kind of had to adjust it and fiddle with it to try to get the wires to run decent. That's my experience with these wires. Put down in the description if there's more wires that you want to see. I know that you guys have been mentioned a bunch of different ones, ESAB and a bunch of others. So I will be picking up some more wire. We'll do some more tests and see where the results end up. But so far, the Lincoln wire is in the lead. And like I said, I'm a Hobart Miller guy. But I can admit when something is the way it is. So red won in this head-to-head competition. New videos every week, guys. I want to thank you for watching. Thank you guys for tuning in. If you're wondering what I'm working on before it makes it up to YouTube, you guys can catch me on Facebook and on Instagram. I'll have links down below, just as I'll have links to all the equipment that you see me using. Now, if you are interested in one of these Fronius welders or you just want to know more about it, again, I'll have links down below, and you'll save yourself a considerable amount of money by going through those links, because it's something that Fronius has provided to our channel. Who doesn't like to save money? Until next week, guys, I will see you then. Take care, stay safe, like, comment, subscribe. See ya.